Have you ever gazed up at the night sky, feeling the vastness of the universe above you, and witnessed a breathtaking display of vibrant dancing lights that seem almost otherworldly? This captivating phenomenon, known as the Northern Lights or Aurora Borealis, has fascinated skywatchers for centuries, leaving them in awe of its beauty and mystery. Imagine a celestial ballet of luminous green, pink, and purple hues shimmering across the darkness, painting the night sky with ethereal beauty. These colors dance and weave through the sky, creating a mesmerizing spectacle that feels almost magical. The Northern Lights, a true spectacle of nature, occur in the high-latitude regions around the Arctic Circle. From the rugged wilderness of Alaska to the vast expanses of Canada, the icy landscapes of Iceland to the fjords of Norway, these mesmerizing lights transform the night sky into a vibrant canvas, captivating all who are fortunate enough to witness them. But what causes this extraordinary display? What is the science behind these dancing lights that captivate our imaginations? The answer lies in a fascinating interplay between the sun and our planet. Solar flares and winds carry charged particles from the sun towards Earth, where they interact with our planet's magnetic field. The Northern Lights are not merely a visual treat, they are a testament to the powerful forces at play in our solar system. These interactions create the stunning light displays that we see, reflecting the dynamic and ever-changing nature of our universe. They remind us of the interconnectedness of our universe and the awe-inspiring phenomena that unfold above us. The Northern Lights serve as a beautiful reminder of the wonders that exist beyond our everyday lives. Join me as we delve into the science behind this celestial dance, exploring how these mesmerizing lights are formed, the conditions that make them possible, and the best times and places to witness them, and how you can witness their magic firsthand. Whether you're an avid skywatcher or simply someone who appreciates the beauty of nature, the Northern Lights offer an unforgettable experience that will leave you in awe of the natural world. To understand the Aurora Borealis, we must first journey to our nearest star, the Sun. The Sun, a massive ball of burning gases, is the powerhouse of our solar system. It not only provides the light and heat necessary for life on Earth, but also plays a crucial role in the creation of the auroras. The Sun constantly releases a stream of charged particles, known as the solar wind, into space. This solar wind is a continuous flow of plasma, consisting mainly of electrons and protons, that travels outward from the Sun in all directions. This solar wind carries with it a piece of the Sun's atmosphere, a plasma of electrons and protons. These particles are highly energetic and travel at speeds of up to 900 kilometers per second, creating a dynamic and ever-changing environment in space. As the solar wind travels through space, it eventually encounters Earth's magnetic field. This magnetic field, also known as the magnetosphere, extends thousands of kilometers into space and acts as a protective barrier against the solar wind. This magnetic field acts as a protective shield, deflecting most of the solar wind around our planet. Without this shield, the solar wind would strip away our atmosphere, making life on Earth impossible. However, some of these charged particles manage to penetrate the magnetic field lines, especially at the Earth's poles where the field is weaker. These particles are funneled towards the poles by the magnetic field lines, creating a concentrated stream of energy. When these charged particles from the Sun collide with atoms and molecules in Earth's upper atmosphere, they transfer their energy, causing the atmospheric gases to become excited. This process occurs at altitudes of 100 to 400 kilometers above the Earth's surface. This excitation is short-lived, and as the atoms return to their normal state, they release energy in the form of light. The color of this light depends on the type of gas and the altitude at which the collision occurs. Oxygen typically emits green or red light, while nitrogen can produce blue or purple hues. This emitted light is what we perceive as the mesmerizing Aurora Borealis. These stunning displays of light can be seen in the polar regions, creating a natural spectacle that has fascinated humans for centuries. The auroras are not just beautiful, they are a vivid reminder of the powerful and dynamic relationship between the Earth and the Sun. The aurora borealis isn't limited to a single color. It often erupts in a vibrant palette of greens, pinks, purples, and even reds. These different colors are a direct result of the types of gases present in Earth's atmosphere and the altitude at which the collisions occur. The most common color observed in the aurora is a brilliant green. This green hue is produced when charged particles collide with oxygen molecules at an altitude of around 60 miles above Earth's surface. At higher altitudes, around 200 miles, oxygen produces a rare, all-red aurora. Pink and purple hues are typically observed at lower altitudes and are often associated with the excitation of nitrogen molecules in the atmosphere. The specific color emitted depends on the energy level of the excited nitrogen. These colorful variations add to the visual splendor of the aurora, making each display unique and captivating. While the aurora borealis is a captivating phenomenon, its appearance is not always predictable. However, scientists have developed tools to help forecast the likelihood and intensity of auroral displays. One such tool is the KP index, a measure of geomagnetic activity. The KP index is a scale that ranges from 0 to 9, with 0 representing very low geomagnetic activity and 9 indicating a major geomagnetic storm. Higher KP values generally correspond to a greater likelihood of seeing the aurora borealis and indicate a more intense and widespread display. Various websites and apps provide real-time KP index forecasts, allowing aurora enthusiasts to plan their viewing opportunities. A KP index of 3 or higher is generally considered favorable for aurora viewing, with higher values indicating a greater chance of witnessing a spectacular show. However, it's important to remember that the KP index is just a prediction, and the aurora's appearance can still be influenced by other factors. In this chapter, we delve into the fascinating world of plasma and the coronal mass ejection, or CME. Plasma, often referred to as the fourth state of matter, is a hot, ionized gas consisting of approximately equal numbers of positively charged ions and negatively charged electrons. The Sun, our closest star, is a massive ball of plasma, and it frequently ejects large quantities of this plasma into space in events known as coronal mass ejections. These CMEs can have profound effects on space weather and, consequently, on the northern lights. When a CME reaches Earth, it can interact with our planet's magnetic field, causing spectacular auroral displays. The charged particles from the CME travel along the magnetic field lines toward the polar regions, where they collide with gases in the Earth's atmosphere. These collisions release energy in the form of light, creating the mesmerizing auroras we see. Understanding the science behind CMEs and their impact on the northern lights can enhance our appreciation of this natural phenomenon. Next time you witness the aurora, remember that you are not just seeing a beautiful light show, but also the incredible interplay of cosmic forces that shape our universe. Now that we've explored the scientific marvel of CMEs, let's turn our attention to the rich cultural tapestry woven around the northern lights. The northern lights have been a source of wonder and inspiration for many cultures around the world. For the Aboriginal peoples of the Arctic regions, these lights hold a special significance. The Inuit of Canada and Greenland believe that the lights are the spirits of their ancestors, dancing in the sky. This belief is deeply rooted in their cultural heritage and is reflected in their stories and oral traditions. The flickering and shifting of the aurora are seen as the movements of these spirits, bringing messages from the afterlife. In Finland, the Sami people have their own interpretation. They call the phenomenon revontulet, which translates to foxfires. According to their legend, the lights are caused by a magical Arctic fox running across the snow, its tail brushing against the mountains and creating sparks that light up the sky. The Aboriginal cultures of Alaska also have rich legends surrounding the northern lights. The Yupik people believe that the auroras are the souls of animals, particularly deer, playing in the sky. They see the lights as a bridge between the earthly and the spiritual realms, a connection to the natural world that is both beautiful and profound. These cultural interpretations of the Northern Lights are not just myths. They are an integral part of the Aboriginal people's worldview. They offer a way to understand the natural world and their place within it, blending science, spirituality, and storytelling. The next time you witness the Northern Lights, take a moment to reflect on these ancient stories. They add a rich layer of meaning to the spectacle, reminding us that the auroras are not just a scientific phenomenon, but also a timeless source of wonder and inspiration. The lights dancing in the sky are more than just particles colliding in the atmosphere. They are a living tapestry of human imagination and belief, connecting us to the past and to the mysteries of the universe. Thank you for joining us on this journey through the magic and science of the Northern Lights. We hope you find your own sense of wonder and inspiration under their glow. Happy aurora hunting!